Hey there, Seahawks. It's Miss Adams, and in this video, we're going to talk about what a sampling distribution is. All right, so a sampling distribution is a distribution of a statistic over all possible samples. So you're going to be taking several samples from a population and calculating a statistic. Now, you need to make sure that when you take those samples, you're taking all the samples of the same size every time. All right, so how to make a sampling distribution. Take a sample size of n. So if n is 5, that means our sample size is 5. We're taking 5 people at a time from the population. If our sample size is 100, we're taking 100 people at a time from the population, and that's what our group size is. Compute the statistic. Your statistic could be a mean, a median, a proportion, a standard deviation, something that you calculate and record it. So you take a sample, you calculate a statistic from that sample, and then you're going to repeat that process many times. And you're going to plot the statistic you calculated from each of your many samples on a dot plot. All right, so what this kind of looks like as a picture, we're starting with our population, and our population is of size n, capital N for the population. The mean is mu, the population proportion is p, the standard deviation is sigma, and then we're taking a sample. So we're pulling out a sample of whatever size. If it's sample size 5, we pick 5 people randomly from the population, and we would record whatever statistic value that I'm taking from the sample. If it's the size, it's lowercase n. If it's the mean, it's x bar. If it's a proportion, it's p hat. If it's a statistic, it's lowercase s. All right, and then we're going to do that again, and we're going to have replacement. So we're going to put them back, mix them up. It'll be random. Then we'll take another random sample from the population of size 5 or size 100, whatever it is, so that it's always the same size every time. Calculate that statistic. Once I have that statistic value, I'm going to plot that point on a dot plot, and then it'll start to make a distribution. The distribution may be normal, it may be skewed, it may be bimodal. It just kind of depends on some other factors that we'll learn about in this unit as well. All right, so an example, pool balls. We will illustrate this concept of sampling distribution with a simple example. You have 3 pool balls numbered 1, 2, and 3. 2 of the balls are selected randomly with replacement. That means I'm going to take one, I'm going to look at what number it is, and I'm going to put it back, mix them up, pick another one. And the averages of their numbers is computed. So I could pick 1 the first time, and then I could pick 1 again. I could pick 1 the first time and 2 the second time. I could pick 1 and then 3. I could pick 2 and then 1, 2 and then 2, 2 and then 3, 3 and then 1, 3 and then 2, 3 and then 3. So those are all of my possibilities. Now the mean, so for the first combination, 1 then 1, 1 plus 1 is 2, divided by 2 is 1. Okay, my sample size n is 2. All right, n equals 2. That's my sample size of my samples I'm pulling. All right, my next mean, 2 plus 1 is 3, divided by 2 is 1.5. 3 plus 1 is 4, divided by 2 is 2. So I'm calculating my statistic, which is my sample mean. My sample means that I'm finding, these are x bar values. All right, so I'm going to take each of those means, and I'm going to plug it in to this distribution over here. So my possible means are 1, 1.5, 2, 2.5, and 3. And if you notice, I have 9 possibilities. So for my frequency, I'm going to go ahead and count by ninths, 1/9, 2/9, 3/9, 4/9, 5/9, just so that it's also as probability, because I can make the fractions into decimals and change those into percentages if I wanted to. All right, so for 1, I have 1 of the 9 possibilities has a sample mean of 1. 1.5, I have 2. 2, I have 3. 2.5, I have 2, and 3, I have 1. Okay, so this is what my distribution looks like. Instead of making a histogram, I could have made a dot plot, and so I would have just drawn dots instead of boxes. All right, so that's what a sampling distribution looks like and how you create one. All right, go Seahawks.